Good day, students. You are welcome to sirMATHS as we journey together in this mathematical journey. You're welcome. Today we are going to discuss an important topic which is we call theory of logarithm. Theory of logarithm. As it affects grade 12, equivalent to SS3. In our previous grade, we treated logarithm using table to solve logarithm table to solve our problem, and on and on. So this time around, we are going to treat the theory. It's a situation where we will solve a log without using table. And also you still remember the properties or laws of logarithm. I will put them down to refresh our memory because we are applying this law as we solve this very problem. Those properties or laws states one, that log m times n base a is equal to log m base a plus log n base a. That is product. This is a product property of logarithm. We also have quotient. That is log m over n base a. This will give us log m base a minus log n base a. We also have power property, which is log m raised to power n base a. This will give us log n log m base a. You were also told that when the base is equal to the log m base n, the result is 1. So we'll be applying these very properties or laws in the issue or the problem we are about to solve in our today's discussion. This is just to refresh your memory. Let's go on to our discussion. Theory of logarithm. Let's have some examples in this issue. We are asked to evaluate the following logarithm. Evaluate means find the values. We have here log 4 base 2. Let's say number 2. Let's have log 25 base 5. Log 1 over 7 base 7. Let's register. We're expected to find a value, of each of these. Like I said, there are methods, so many methods of solving a particular question in mathematics. For this number 1, which is log 4 base 2, it can be solved this way: log 2 raised to the power 2 base 2. 2 raised to the power 2 will give us 4. And applying the third law, this is 2 log 2 base 2. Here you can see that the log is the same as base, which we say the result will be 1. So our result here will be 2 times 1, and that is 2. We have found the value of log 4 base 2 to be 2. Number 2, log 25 base 5. This is log 5 raised to the power 2 base 5. 5 raised to the power 2 is 25, giving us 2 log 5 base 5. And this will result to 2 times 1, that is 2. Number 3, log 1 over 7 base 7. This is log 7 raised to the power minus 1 according to indices base 7. And we now have, according to the third law here, minus 1 log 7 base 7. That is, will result to minus 1 times 1, because log 7 base 7 is 1. And we now have minus 1 as our answer. We have been able to evaluate log 4 base 2, log 25 base 5, and log 1 over 7 base 7. We may have another, let us handle a question like this, in addition to the examples we have already treated. We are asked to evaluate log 0.25 base 16. So we have log 25 over 100 base 16. I've converted the decimal fraction into ordinary fraction. This will give us log 25 here 1, 25 here 4 base 16. And that will give us log 4 raised to the power minus 1 base 4 raised to the power 2. 4 raised to the power 2. 4 raised to the power 2 is 16. And this will give us minus 1 over 2 log 4 base 4. And that will result to minus 1 over 2 times 1. And our answer is minus 1 over 2. Remember, we expressed this 0.25 decimal fraction into ordinary fraction. This is 0.25, 2 decimal places. That is why we have 2 zeros over 100. And this will be our result. That is in the aspect of evaluating a given logarithm. This is what we apply. Like I said, there are many other methods. Alternative method of this can be in that example 1, that log 4 base 2. Somebody can say, let log 4 base 2 be x. And that means log 4 base 2 equals to x. And that means 2 raised to the power x is equals to 4. We have now expressed the log into index form. And you know that 4 is the same thing as 2 raised to the power 2. So we now have 2 raised to the power x is equal to 2 raised to the power 2. So the base cancels the base because they are the same. This is 2, remember. So we now collect the remnant. So we now have x is equal to 2. That is what the same thing we got previously. And the other methods. So this is alternative method to the one we used before. We are treating evaluation. I hope this aspect is clear to every one of us, evaluating a given log. There are situations we'll be given the log value from the table, and we expected to use those given log values of the table to solve a problem. And by that, we expected to restrict ourselves only to that very given log value in solving that problem. What do I mean by that? Let's have example. You are given the value of log 2. Let's say given that log 2 is equal to 0.3010, and log 5 or log 3 is equal to 0.47771, and then log 8, or rather log 7, equals to 0.8451. And the question says, with this very given log value, evaluate log 49 as A, also log 5, and lastly, for this example, log 8. By this question, we expected to use only these given logs. 1, 2, 3. We're not expected to go to the table to solve each of these very questions. For the first one, let's label it A, log 49. Log 49 is log 7 raised to power 2. And this is by the third law, this is 2 log 7. We now pick the value of log 7 as given times 0.8451, resulting to 2 times 1 will give us 2, 2 times 5 is 10, 0 carry 1, 2 times 4 is 8, 8 plus 1, 9, and 2 times 8 is 16, we write 6 and carry 1, and 2 times 0 is 0 plus the 1 we carried, 1. We have evaluated log 49 using the given log. We now have log 5 as B, log 5. If you check very well, you discover we are not giving log 5 here. There's no log 5, and you cannot say log 2 plus log 3. No, we don't do that. It's a product. We manipulate this very 5 to enable us make use of what we have here. We now have log 5 is descending as log 10 divided by 2. 10 divided by 2 will give us 10 divided by 2 will give us 5. So we apply the second law, which says that this will be log 10 minus log 2. Log 10, you don't need to be given log 10, because in every log where the base is not given, it's automatically base 10. Whenever you're not giving base of any logarithm, it's automatically base 10. So what we have here is log 10 base 10. We don't need table, and we don't need to be given that. We know that will give us 1. So like I said, this becomes log 10 base 10 for clarity's sake, minus log 2 base 10. So this is 1 minus, we're already given log 2 to be 0.3010. We subtract For clarity's sake, this is 1.0000 minus 0.3010. Of course, in your level, you don't even need this, but those who may get confused. 0 minus 0 will give us 0. We carried 1 all the way, so this will become 10. 10 minus 1 is 9. This remains 9. 9 minus 0 is 9. This remains 9. 9 minus 3 is 6. And already we have carried this one, so we now have 0 because it's gone. We have evaluated log 5 using the given log values. Let us quickly look at the other one, log 8. Log 8. Log 8 is the same thing as log 2 raised to power 3. 2 raised to power 3 will give us 8. That is 2 times 2 times 2 is 8. By the third law or third property, this is 3 log 2. So this will give us 3 times the value of log 2 already given, 0.3010. 3 times 0 is 0, 3 times 1 is 3, 3 times 0 is 0, and 3 times 3 is 9. 3 times 0 is 0. We have evaluated this. So this is the value of log 8 using the given log values. However, remember to subscribe to sirMATHS. Turn to your notification so that you'll be updated daily in every of the week in this our mathematical journey. I want to thank you for your audience and for subscribing. We continue. We have not gone halfway of the theorem of logarithm. I want to promise you in our next meeting we continue from where we stopped until we treated this completely. Once again, thank you for listening. Bye.